Let's do step one. So here we determine the characteristic equation. So we write the characteristic equation for a square matrix A, that is A minus lambda I, and this determinant equals 0. So this basically represents the characteristic equation. We can expand this characteristic equation by subtracting lambda from the diagonal elements of the matrix A. So therefore, we can write down this as I'm going to subtract lambda from each of the diagonal elements. So this becomes 0 minus lambda, 4, negative 1, and 1. The next diagonal element is 3. So I subtract 3 lambda from 3 and then negative 1. And finally, the fourth row, we have the diagonal element negative 1. So we subtract lambda from this one, negative 1, negative lambda. And we have to determine its determinant. This is lambda. And this determinant equals 0. So when we expand this determinant, we will get the characteristic equation. I'm going to expand it along the third row because I see that there are two zeros in the third row when compared to the other elements or the other rows. So when you expand along the third row, I put this element negative 1, negative lambda, then multiply with by removing or just ignoring the corresponding row and the corresponding column. When I do that, I will get 0 minus lambda, which is negative lambda, and then 4 and 1 and 3 minus lambda. So we get 2 by 2 determinant, and this equals 0. Now let's expand the 2 by 2 determinant. Here we have negative 1, negative lambda multiplied with negative 4 times of 3 minus lambda. So I'm sorry, that is negative lambda times of 3 minus lambda, and then minus 1 times of 4, which is 4, negative 4. And this equals 0. So here we have negative 1, negative lambda. Let's simplify this by distributing this negative lambda. This becomes negative 3 lambda. Negative lambda times negative lambda is positive lambda squared, and then we have negative 4. This equals 0. So here we have to do the distribution. First, I distribute this negative 1 with all the terms inside the brackets. So negative 1 times of all the terms. This basically we just have to flip all the terms. That is, we have to flip its signs. So it will be 3 lambda minus lambda squared plus lambda. I'm sorry, plus 4. We then multiply with negative lambda, which each of the terms inside the brackets. So negative lambda times negative 3 lambda is positive 3 lambda square. And then negative lambda times positive lambda square is negative lambda cube. Then negative lambda times negative 4 is plus 4 lambda. This equals 0. Let's put this in order. I'm going to put lambda cube first, that is negative lambda cube. Now we simplify the like terms, that is negative lambda square plus 3 lambda square, and this equals positive 2 lambda square. And then we collect this 3 lambda and 4 lambda, which is 7 lambda. So I put this is 7 lambda here, plus the remaining term is 4. That is the number, and this equals 0. So this is basically the characteristic equation for the given matrix. Let's do step 2. So in step 2, we have to determine the powers of A. That is, we have to determine A power 2 as well as A power 3. First, we will determine this A power 2. That is A power 2, and this equals A multiplied with A. So I'm going to replace A matrix, that is 0, 4, negative 1, 1, 3, negative 1, 0, 0, negative 1. So this has to be multiplied with itself, that is 0, 4, negative 1, 1, 3, negative 1, and 0, 0, negative 1. So here we use the matrix multiplication concept. That is, we have to first consider the first row in the first matrix, multiply with each of the columns in the second matrix. So first we have to multiply with this column, and then this column, then we have to multiply with this column, and then we have to multiply with the third column. So let's do that. I'm going to do it separately over here. That is, 0 times 0 is 0, plus 4 times 1 is 4, negative 1 times 0 is 0. So the first element is 4. I write down 4 here. Now I consider the first row as well as the second column, multiply the corresponding elements. So 4 times 0 is 0, plus 4 times 3 is 12, and then negative 1 times 0 is 0. So the next element is 12. Now I consider the next column. So it is 0 times negative 1 is 0. 4 times negative 1 is negative 4. Negative 1 times negative 1 is positive 1. So negative 4 plus 1 is negative 3. So we have completed the first row. Now we have to consider the next row, that is the second row in the first matrix. And we have to do the same thing. That is, we have to first consider the first column, second column, and then the third column. So I'm going to first multiply with the first column. So it is 1 times of 0 is 0, plus 3 times of 1 is 3, and then negative 1 times 0 is 0. So it is 3 plus 0 is 3. Now I consider the second column and multiply with this second row of the first matrix. So it is 4 times 1 is 4, then 3 times 3 is 9, and 0, which is 13. 4 plus 9 is 13. And finally, we do the third column. So it is negative 1, negative 1, negative 1. So it is basically the negative of these elements. So it is negative 1, negative 3, and positive 1. So negative 1, positive 1, 0, and this is negative 3. Now I consider the last row of the first matrix, multiply with each of the columns in the second matrix. So it is, since we have two zeros here, we just have to multiply this element with the corresponding this element. So negative 1 times of 0 is 0. And similarly, when we look at the second column, this is negative 1 times of 0 is 0, and negative 1 times of negative 1 is positive 1. So basically, this is the matrix A power 2. Now we will determine A power 3. So A power 3 is obtained by multiplying the A power 2 matrix with A. So I'm going to replace A power 2 matrix, that is 4, 12, negative 3, this matrix, and this is 3, 13, and negative 3, and 0, 0, negative 1. So this has to be multiplied with A matrix. A matrix is 0, 4, negative 1, 1, 3, negative 1, 0, 0, negative 1. So let's do the multiplication. So first we consider the first row of the first matrix and then multiply with each of the columns in the second matrix. First I multiply with the first column. So 4 times 0 is 0, plus 12 times 1 is 12, and negative 3 times 0 is 0. So we get 12 as the first element. And then we now move on to the next column. 4 times 4 is 16. 12 times 3 is 36. Then negative 3 times 0 is 0. So 16 plus 36 is 52. Now let's multiply with the third column. So in third column, we have all the negative 1, which means we just have to take the negative of the first row. That is negative 4, negative 12, and positive 3. So this is negative 4 plus 3 is negative 1. Negative 1, negative 12 is negative 13. Now we have completed the first row. Now we move on to the second row of the first matrix. So here we now start off with the first column, that is 4 times, I'm sorry, 3 times 0 is 0, 13 times 1 is 13, negative 3 times 0 is 0. So this is 13. Now let's move to the second column. 3 times 4 is 12, 13 times 3 is 39, negative 3 is 0. So this is 12 plus 39 is 51. And finally, the last column, 3 times. So we have to take the negative of the second row. It is negative 3, negative 13, positive 3. So these two gets cancelled. We have negative 13. Now let's move on to the third row of the first matrix and multiply with each of the columns in the second matrix. So since we have two zeros here, we just have to look at only this product, that is the last element of the third row multiplied with each of the elements in the columns, like this. So negative 1 times 0, 0, this will be 0, and this will also be 0. And finally, the last element will be negative 1 times negative 1 is, this has to be positive 1. I'm sorry, I have actually written this as negative 1. This is positive 1. So this has to be positive 1 and not negative 1. So now when we multiply, we'll get 1 times of negative 1 is negative 1. So this will be negative 1. So this represents the matrix A3. Let's do step 3. So here we write down the matrix version of the characteristic equation. So first let me copy the characteristic equation, that is negative lambda cube plus 2 lambda square plus 7 lambda plus 4 equal 0. So in this equation we have to replace all lambda by a. So therefore this becomes negative a cube or a power 3 plus 2a power 2 plus 7a plus 4. Here we have to write down 4 times of I3 because it's a square matrix of order 3. So we put 4I3 and this equals 0. So this completes the step 3. This is the matrix version of the characteristic equation. Let's do step 4. So here we substitute the powers of A into the matrix equation that we determine in step 3. So we first put negative A cube, that is negative of A cube, which is 12. In fact, I can write down every element in negative quantity. So I consider this A cube and I put the negative of each of the elements. So that is negative 12, negative 52, positive 13, then negative 13, negative 51, positive 13, 0, 0, and positive 1. So this is negative A cube. And then I put plus 2 times of A power 2. So this A power 2 matrix has to be multiplied with 2. I'm going to multiply each of the elements of A power 2 with 2. So therefore it will become 4 times of 2 is 8, 12 2 is 24, negative 3 times 2 is negative 6, 3 times 2 is 6, 13 times 2 is 26, negative 3 times 2 is negative 6, and then 0, 0, 1 times 2 is 2. So this basically represents 2a cube. Sorry, this is 2a square. Then we have plus 7a. So I'm going to multiply the matrix A by 7. So it can write down here. This is plus 7 times of A. Otherwise, I multiply each element by 7. The first row will be 0, 28, negative 7. 0, 28, negative 7. And when we multiply the second row by 7, we get 7, 21, -1 times 7 is -7, and the last row is 0, 0, -1, so it becomes 0, 0, -1 times 7 is -7. So this is 7a. And finally, we have 4 times of I3. I can write down this I3. This matrix is a square matrix. It's an identity matrix. As we know that this is the I3 matrix, and we multiply this by 4. We'll get 4 here, and 4 here. I can put this here, that is 4, 0, 0, and then 0, 4, 0, 0, 0, 4. And this should equals 0. Let's verify that. Now it's just a matrix addition of these matrices, that is negative a cube plus 2a power 2, then plus 7a plus 4i3. This represents 4i3. We have to add these elements, corresponding elements. So the corresponding elements are negative 12, 8, 0, and 4. So as we can see, this is 8 and 4, which is positive 12, and then we have negative 12. So they become 0. So the first element will be 0. Similarly, we will add the corresponding elements for this column, that is negative 52. We have 24 plus 28 is 52. So 52, negative 52, this will also become 0. So likewise, if we continue to do this, we get all zeros. This is 13, this is negative 6, negative 7, and here it is 0. Negative 7, negative 6 is positive 13, and this 13. So this becomes 0. Similarly, when we do the other elements, that is adding the other elements, we get this is 6, 7, 13, negative 13, 0, and also 26 plus 21 is 51. So we have negative 51, 0, and then negative 6, negative 7 is negative 13. We have positive 13 here, which is also 0. And finally, for the last row of elements, this is we just have to consider only this last element, because the first two elements are 0 in each of the matrices. So here we have 1, 2, 3, 3 plus 4 is 7, 7 and negative 7 is 0. So we can clearly see that we get all zeros, and this equals 0. This in fact is true. This is a 0 matrix, 0 equals 0. So this is true. So we see that the matrix equation is true. Equation is true, which means we choose yes for this step.